Okay, so I hope that we're all doing well on this wondrous, wondrous, wondrous day. Um, we are gonna pick up where we left off, and we're just gonna figure this out. We're not gonna watch this whole video. We're only gonna watch like little parts of it. I'm gonna be jumping around amongst a whole bunch of different parts of it to kind of make sure that I understand things. Right before I went live, I did kind of have a little bit of a revelation, or at least I think I did. So we're gonna kind of understand that. We're gonna do our best to kind of understand that. We're gonna ask our AI assistant here, good old Claude, okay, to try to make sure that what I think is right is correct, stuff like that. I hate when the visuals go away. There they are. The visuals help me out so much. Anyway, so we're gonna go ahead. We're gonna get directly into it. I hope that everything's working. That sounds whatever. So we're gonna dive directly into this. So let's see here. So this was the question that was presented on day 13. Now we did already technically answer it. However, I want us to look at it again because I was doing it wrong before. And was I smart enough? I was smart enough. Fantastic. Okay, so what we're going to do is that we are just going to try this one again from scratch, and we're going to see how it goes. So basically what we're doing here is that we have our subnet, right? Our subnet mask. Ooh, I didn't think about that one. So we have our subnet mask. What are the remaining subnets? So this right here is the network that has been assigned to this router. So that means that all of the IP addresses that are available are here. Should be, at least, if I understand it correctly. I'm going to make this bigger. Can I do that? And then move this there. And move this like there. Okay. Okay. So what does this mean? What does that mean that we're going to do here? So what we have to do is figure out the frozen bits and the free bits. Luckily, it's 24, so we know that each octet is taken. So we have octet 1, octet 2, and octet 3 are all taken. So that equals 24. And then we have 8 bits that are over here that are free. Okay? Free. Which means that it's going to be 2 to the 8th power is going to get us all of the addresses, not all the usable addresses, but all the addresses in general. And can I get a calculator up here? Google's so much better than the calculator app that I have. Someone needs to make a better calculator app for Windows. I feel like it's not that great. So 2 caret key 8, 256. Okay, that's what I thought. 256. Now we subtract 2. Okay? And the reason we subtract 2 is because 1 is the network and 1 is the broadcast. Okay, this all makes sense. Now where people kind of get confused and what was really messing me up the other day, I think it was like Wednesday, probably both days, honestly, was that we count 0. Okay? 0 is a very tricky thing, okay? I could explain it to you in music, but that probably ain't going to do you any good. Just know that we count 0, okay? And the way I made it make sense in my brain is the way I know how rhythm works. Okay? If you're interested in that, just let me know and I can explain that. But it's really not that necessary. So we have 254. That means we have 254 addresses to be divided up 4 ways, because we have this guy, we have this guy, we have this guy, and we have this guy. So can 254 go and be split 4 ways? Okay, well, let's find out. 254 divided by 4. 63. Yes, it can. Because we need... How many addresses do we need? I think we needed 45. I think each one needed 45. It's not written, but I'm pretty sure that's what we needed. Okay, so then let's figure out how many usable addresses we have within one network. Okay, so this is definitely like subnetting a subnet. So we have all 8. Now I'm now looking at this one. Okay, we now have all. I'll do it in a different color. We'll do it in blue. Okay. So we have all 8, we have all 8, we have all 8. That makes 24, 25, 26. So that means that this is now 6. So our new equation is 2 to the 6th power. And 2 to the 6th power should be like 90 something, right? 2, where's the power symbol? Okay, whatever. 2 to the 6th power. No, that's not right. Okay. Yeah, 64. I think I might have said 90. Anyway. Okay, 64. Now, I'm pretty sure we needed 45 addresses. I think that was the original question, is that each subnet needed at least 45. And 64 was the closest we could get to that. So we are wasting a few addresses, but we're not wasting that many. So that's okay. Okay, that means that if we minus 2, it's actually 62 usable addresses. So theoretically, all we have to do, that means that we took this subnet that was broken down into /24, meaning that we're using the C-class addresses. This whole octet is free for us, so we have 256 addresses and 254 addresses rather that are usable, and we need to divide those into 4. Can we do that? Yes, we can easily do that. So we're taking it and we have 64 addresses in each one. So and that's why this is 0. This is 0 because that is the network for this subnet, for this router, or sorry, switch. So theoretically, all we should have to do is just add 64 to whatever the octet is, the last octet, or the interesting octet. So this should be 192, and let's do this over here. I don't know why it's so light all of a sudden. 192.168.1.64, because that should be the next network. Now, we should just be able to continually add 64. That's not a 6. That's supposed to be a 2. And then 64 plus 64, 8, 128. Okay. Of course, it has the /26. Okay. And then 128 plus 64, 4, 8, 12. Carry the 1. That's 3. This is a 6. I know it doesn't look like it, but it's a 6. 6, 7, 8, 9. 192. So I'm just going to put 192. And of course, it is /26. So that theoretically should be the answers. This. Oh, there's supposed to be a point right here. This. Those should be it. Let us move this back over here. Okay, good. Let's listen to it.
Into 4 subnets that can accommodate 45 hosts each. We found that a /26 subnet is the right size to fit 45 hosts. so we assign the block 192.168.1.0/26 to subnet 1. If you don't remember how we determined that /26 is the correct size, take a minute to review the end of the last video. So I asked you to find the remaining subnets. I also
Basically what we did a long version of it where we pretty much went through 24 we went through 24 and 25 and 26 to see how many subnets that are in there. Now I'm gonna write this down. I'm gonna make a list of notes of things that I have questions about, and one of the things I have questions about, actually no, I'm just gonna write it here. The difference in no, let's do vocabulary. No, let's do terminology. Terminology. That is not how you spell terminology. Is it? Yeah, I didn't think so. What did I misspell? Oh, there's no A. And there's another. Oh, terminology. Okay, that makes sense. Okay, what is the difference in terminology with subnet? Network when it is in regard to subnetting. There's another one that I get confused with all the time. Subnet of a subnet. What, subnet's wrong? No, you just think that's what I want, but I'm not done listing. And then I get really confused with targeted octet. Targeted octet is, and how it is connected, and how it is, and all of these are connected. I'm not going to send that just yet because I'm probably going to have more questions. So,
also gave you this hint. If you find the broadcast address of subnet 1, the next address after that will be the network address of subnet 2. So, the network address for subnet 1 is 192.168.1.0/26. Here's 192.168.1.0 written in binary. Blue is the network portion, red is the host portion, and purple is the part we borrowed from the host portion to add to the network portion. This allows us to divide the larger /24 network into multiple smaller subnets. To find the broadcast address for this subnet, which is the highest address in the subnet's address range, set all of the bits in the host portion to 1. Next, let's convert this to dotted decimal. It becomes 192.168.1.63. That's
okay, so this little method right here is new to me, and it definitely is kind of mind-boggling. So we're going to go back and we're going to listen to that again. I'm going to kind of turn it up because it's a little low on my end. It should be fine on y'all's end. If it's not, let me know.
Next, let's paste address in this work into mode from the blue /26. Here's 192.168.1.0 written in binary. Blue is the network portion, red is the host portion, and purple is the part we borrowed from the host portion to add to the network portion. This allows us to divide the larger /24 network into multiple smaller subnets. To find the broadcast address for this subnet, which is the highest address in the subnet's address range, set all of the bits in the host portion to 1.
Okay, so what he did, in order to find the broadcast number, he just set all the free bits to 1, meaning that they'd all be used. Because the broadcast isn't always, shoot, why did that just happen? What? Okay. The broadcast isn't always 255. So, like, for instance, the broadcast for subnet 2, that's right here, is 127. 127. Now, I do wonder how that works. Okay, hold on. Let me reconcile that. Because that gets you the broadcast for subnet 1, but how would that get you the broadcast for subnet 2?
Next, let's convert this to dotted decimal. it becomes 192.168.1.63. That's the broadcast address. So the address range for subnet 1 is 192.168.1.0 through 192.168.1.63. The network address of subnet 2 will be one higher than the broadcast address.
Okay.
So that means that subnet 2 will be 192.168.1.64/26. That's the network address, and here it is in binary. Notice that we changed one of the bits we borrowed from the host portion to a 1. So the network address is now 192.168.1.64, with all of the host bits set to 0. Now let's find the broadcast address. Change all of the host bits to 1, and now let's convert it to dotted decimal. So the broadcast address is 192.168.1.127.
He did it. Okay, so he did exactly what I did, except he's just showing you how it works with binary. So the last one started with 0, and then he changed them all to 1. So then 0 plus 64 was 64. And then now we're starting with 64. He changed all the other ones to 1s, and now it's 127. Okay.
So that's the range for subnet 2. Add 1 to the broadcast address, and we'll get the network address for subnet 3. So that means subnet 3 is 192.168.1.128/26. Here is the network.
Connection successful. So did it make another stream? Can you see this? No, you guys. Okay, it's fine. Hold on. I just need to double check this because I don't know what's been going on with OBS lately. It's been disconnecting my streams. Okay, it seems like everything's okay. Anyway.
And here's the broadcast address. So the address range for this subnet is 192.168.1.128 through 192.168.1.191. Now we can find the last subnet, subnet 4. Subnet 4 is 192.168.1.192/26. Here is the network address in binary. This time the borrowed bits are all 1, so this is our last subnet. We don't have any room for more. Change the host bits to 1, and here's the broadcast address. So the address range for subnet 4 is 192.168.1.192 through 192.168.1.255. Okay, we found the answer to the quiz. You may notice something about these numbers. 0 plus 6.
I understand this so much better now. Now, another question I have. How do I find the network address within a subnet? Like, here, let's just give it one. What was that? Sure, this is fine. Let's can I copy paste this? No, I can't. 76.54.8. For example, 76.54.8 176/9 176/9. So this is a really big subnet. How do I know, or how do I figure out what the network address is of this? Okay. We're going to fire these off in a second. Let's keep going. I'm sure I'll have more questions.
64 equals 64. 64 plus 64 equals 128. And 128 plus 64 equals 192. I said last video that I would just show you the basics of subnetting, not any special subnetting tricks, but let me show you just one that can help you figure things out faster. So, we found that a /26 subnet mask is appropriate. That's because there are 6 host bits, which allows 62 hosts. Let's draw this line here. On the left side is the network portion, and on the right side is the host portion. Since we're just looking at the last octet, let me make it bigger. Okay, so I've put the binary for just the last octet down here. Again, the red part is the host portion, and the purple part is the bits we borrowed to expand the network portion. You should remember the value of each binary bit, but let me put them up here anyway. From the right, 1, 2, 4, 8, 16, 32, 64, and 128.
This is a different
Notice that the last bit of the network portion is 64.
Still.
This means that to find the next subnet, we just have to add 64. Let's see. Add 64 and we get 192.168.1.64, which is the network address of subnet 2. Add 64 again, and we get 192.168.1.128, which is the network address of subnet 3. Finally, add 64 again, and we get 192.168.1.192, which is the network address of subnet 4. So, as you can see, by adding 64 each...
Okay. Because I'm thinking like, okay, what if it was /24? Because then there are no borrowed bits to do that little trick. But then it wouldn't. But you wouldn't need that because it would just use the entire octet, and you would know that it would be 0 to 254, or 255 rather. Okay.
Each time, we were able to find the network addresses of each subnet. Now let's try another similar exercise. We have been given the 192.168.255.0/24 network, and have been asked to divide the network into 5 subnets of equal size. In this case, the number of hosts in each subnet hasn't been specified. So let's make 5 subnets that are as large as they can be. So all we have to do to solve this problem is find how many bits we have to borrow from the host portion. Currently, we are borrowing 0 bits from the host portion. That means that we can't make any subnets. We just have one network, 192.168.255.0/24. If we borrow 1 bit, it now becomes a /25 network. Borrowing 1 bit also means we can make 2 subnets. Why is that? Well, all of the original network bits, the blue bits, cannot be changed. That is the network we received. However, the purple bit, the bit we borrowed from the host portion, we can change, and it can be either 0 or 1. If it's 0, we have the 192.168.255.0/25 network.
Okay.
If it's 1, we have the 192.168.255.128/25 network. The formula for the number of subnets is 2 to the power of x, and x is the number of borrowed bits. This is similar to calculating the number of hosts in a subnet, which is 2 to the power of n minus 2.
Okay. The number of subnets. Let me add... difference in terminology with subnets, networks, and hosts. It's because these words all kind of mean the same thing, but they're all different, and then they're sometimes they're used interchangeably.
And n is the number of host bits. We subtract 2 for the network address and broadcast address, which can't be assigned to hosts. However, when calculating the number of subnets, we don't have to subtract 2, so it's simply 2 to the power of x, the number of borrowed bits. Anyway, we need 5 subnets, so borrowing 1 bit isn't enough.
Okay, so how does finding the number of subnets, which is 2 to the power of borrowed bits, relate to the targeted octet? It's going to know what that means because of the thread. So how does the, number of subnets connect to the targeted octet rounded down? And then also, because I'm starting to think that I'm asking the same question over and over again. So I'm very interested in what its answer is going to be. It's probably going to connect all of them and tell me exactly what's going on. Isn't the number of, number of subnets? Yeah, number of subnets is 2 to the power of borrowed bits. Subnets 2 to the power of borrowed bits. Yeah, I don't know why I started doing that, spelling it that way. It's fine.
What if we borrow 2 bits like this? Well, 2 to the power of 2 is 4. So borrowing 2 bits allows us to make 4 subnets. Still not enough. We need 5. So let's borrow another bit. If we borrow 3 bits, how many subnets can we make? 2 to the power of 3 is 8, so we can make 8 subnets. So this is our answer. It's more subnets than we need. We need just 5. But if we borrow only 2 bits and use a /26 mask, we won't have enough. As I said in the last video, you can't always make the numbers exactly match the number of subnets or number of hosts you need. So our first subnet will be 192.168.255.0/27. Here it is written in binary. Here's the network portion, and here's the host portion. Let's look at just the last octet once more. Here's just the last octet. What's the value of the last bit of the network portion? It's 32. So using the trick I introduced before, we should be able to calculate the other subnets now. As I said before, subnet 1 is 192.168.255.0/27.
So you should just be able to add 32 to all of them to figure out the subnets of every single one.
32, and we get subnet 2, which is 192.168.255.32/27. Add 32 again, and we get subnet 3, 192.168.255.64/27. Subnet 4 is 192.168.255.96/27, and subnet 5 is 192.168.255.128/27. Okay, we made up 5 subnets, as our requirements were to divide the network into 5 subnets.
Okay, that's simple. That makes
However,
sense.
our /27 prefix length allows up to 8 subnets to be made from the address range. These 3 remaining subnets are 192.168.255.160,
Yeah,
dot
but we don't
192,
need those.
and .224/27. Here's another type of subnetting question you might find. What subnet does host 192.168.5.57/27 belong to?
Okay, let me see if I have this one. Let's see here. 26, no. 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 Thought I had this one already written down. No. Oh, that's why that was like that. Okay, and then this one is just that. Okay. Let's figure this one out then. So what subnet does this host belong to? Basically, we need to figure out its network. Okay? So, can we just refresh this? Thank you. One 55727. So that's 8, 16, 24, 25, 26, 27. So then our line is right here. So we have our 3 bits on this side, and we have 1, 2, 3, 4, 5 bits that are over here. So 5, and then we have 3. So the way we're going to figure... Man, see, it... Oh. Okay. What we need to figure out... I think it just kind of figured it out. Okay, this is going to... Just kind of stay with me, okay? Because I'm kind of talking out loud right now. Okay. So 27, we need to figure out how many subnets it's going to have. So what we have is, to figure out the number of subnets it has, it's going to be 2 to the power of 3. So 2 to the power of 3, 2 times 2 is 4, 4 times 2 is 8. So we have 8 subnets. Each subnet is going to have how many usable addresses? Right? Am I doing this correctly? So 2 to the power of 3 minus 2 equals 6. So there's going to be 6 usable addresses. Okay. So then, but then what number do we start with? So the octet in question, the interesting one is octet 4. The mask value. So why is the mask value of the interesting octet important? Shh, no, no, no. I hate when it does that, dude. Why is the mask value of the interesting octet in... Dang it. Why is the mask value of the interesting octet important, and how does it relate to finding the network that the subnet is on? No, that the subnet belongs to. Okay. Because from what I understand, okay. Is the mask value in the interesting octet the total of the bits that are frozen or that are free? Is the mask value in the interesting octet the same as the mask? Basically, like if I figure out the mask here, is that the same as that? I think it is. And then these two things. So then why do I need to know the block size? Oh shit, the block size will tell me. Okay. Why do I need to know the block size, and how does it relate to the subnet mask and the network that the mask belongs to? Is it is the block size the number of addresses that are in the subnet? And then could I use that number to find the host network address? See, I don't know if I'm using the correct terminology here. Okay, so what I think I just kind of had a revelation with is that if I'm correct, this is the total of these numbers. So that should be 128 plus 64 plus 32 equals 224. I'm like pretty sure. $224. Now to get the block size, 256 subtract 224. So then what's that? Ugh, whatever. 256 subtract 224. So it'd be 32. But that's not what I got over here. Okay. And then there's got to be like there's like a multiple of something. So I think the host network is 32.
So we have the IP address of a host, 192.168.5.57, and we don't know the network address of the subnet. Let's see how we can figure this out. It's actually a fairly simple process. Here's 192.168.5.57 in binary and dotted decimal. However, it's /27, so let's show the borrowed bits. These 3 purple bits are borrowed and added to the network portion. Now, to find the network address, we simply need to change all of the host bits to 0. Now, the last octet is 00100000. Change that back to dotted decimal, and you get...
He just blew my mind. Okay, we're going to send this off. So, he said in order to find the host network, he turned all... Oh, shit. So, in order to find the host network... So, okay, hold on. I know that I keep not finishing my sentences is because I'm trying to figure it out myself. So... Okay, so we know that this is the subnet. So if we say 32 is right here, which is our block size, okay, and then we turn all these to 0, all we have to do, then we just figure out that it's this. To figure out what block that this is in, we just add it to whatever this side is. So we just add these bits and to this something. Oh man, I'm so close. I can feel it. Okay, hold on. Do it again.
57/27 belong to. So we have the IP address of a host, 192.168.5.57, and we don't know the network address of the subnet. Let's see how we can figure this out. It's actually a fairly simple process. Here's 192.168.5.57 in binary and dotted decimal. However, it's /27, so let's show the borrowed bits. These 3 purple bits are borrowed and added to the network portion. Now, to find the network address, we simply need to change all of the host bits to 0.
No, that's what I was missing. So, no, redo that. So we have to write this out in binary. This might be a slow way to do it, but it's definitely a way to do it. So if we write this out in binary, which is 0, 0, 1, 1, 1, 0, 0, 1, then we know that our host is 32. Because this is our address that we're actually using, and it's being added to the mask. Or it's being added to the network. So that means if this was a 0 and this was a 64, 1, 2, 8 and 16 is 32, 33. So it's 33 plus 64 would be 33 plus 64. 3, that's not 12, that's 8. That's not 8. Why am I struggling with that? 7, 6, 9. So it's 96. So if this was 97 and I wanted to know what its host was, I would write it out in binary. And then I would figure out this. And then that would tell me what subnet it's in. I think. What's Claude telling me? Okay.
Great list. And questions 4 through 8 are all actually the same question wearing different hats.
Yeah, that's what I thought.
So let me answer in an order that shows how they chain together. Terminology. A network is any block of addresses defined by a prefix. 76.0.0.0/9 is a network. 169.54.0.0 is a network. A subnet is just a network that was made by splitting a bigger one. The words are relative, like parent.
Kind of, but they're important. So a subnet is just a network that is made by splitting a bigger one. Okay, that makes sense. Because all the networks of the class is just like /8/16/24. Okay. Because it broke it up in there. And then if it's smaller numbers than that, then we're breaking up that octet. Okay.
Parent and child. 169.54.0.0, 169.0/19ly, in its own right that contains host. In it simultaneously, a network is a host living inside. Is a host living inside 169.5.
Oh, I hate when it does that. Okay, just read this to me, please. And now it's broken. A host is single usable.
Terminology. A host is a single usable address inside a network. Is a host living inside 169.5.
Okay, so this is a host that's living inside of this. So a host is a usable address that's living inside of the network or the subnet. A subnet of a subnet just means that you split the child against 16, 19, 21, each level tilling perfectly inside its parent. So it just keeps getting smaller and smaller. Okay, and the target octet rounded down is the mechanism step that finds which block your address lives in. It converts. I'm standing in 20. Standing at 26. My fence post is 0.
Great list. Finding the network of 76.54.8.176/9. Same recipe every time. 4 steps. First, where does the line land? /9 means 8 bits frees the whole first octet and 1 bit reaches into the second. So the interesting octet is the second one. Second, mask value in that octet equal to the place values of the frozen bits. 1 frozen bit equal to 128. Third, block size equal to 256 minus 128 equal to 128 at 0 and 128 only.
Okay, hold on. So how do we get 128? So the interesting octet is the second one. Second, the mask value in that octet, the place value of the frozen bits, 128. So it is the total of that. So then 128 subtract 26 equals 28 because 128 plus 128 is 156. So networks in that octet start at 0 and at 128 only. Fourth, the target octet is 54. Round down to the nearest multiple of 128. Then 0 everything else out, which is exactly what he was just doing over here. Notice that the 0.8 and 0.176 didn't matter at all in my original example. Yeah, no, those are, yeah, because we only care about the part that's in the front. You're right. Number of subnets is 2 to the power of borrowed bits. These two things answer different questions. 2 to the power of borrowed bits tells you how many blocks exist. So this is telling me that there are 8 blocks that exist. So there are 8 subnets. Okay, so I was correct. So there's 8 subnets inside of it. We have to figure out which subnet this address falls into. So that means that our subnets are going to be our subnets are going to be 0.8, 0.16, 0.24, God, I'm so bad with my 8s. What is 4 times 8? Isn't it 32? Can I double check that? I don't want to be an idiot on stream. 8 times 4 is 32. Good. Okay. Then 32 plus... Dude, I hate when it does that. Why do you do this? 32 plus 8 is 40. Here, let's move that a little bit closer. 40, 48, 52. So we have 1, 2, 3, 4, 5, 6, 7. No, that's not right. That can't be right. Because then it would be 60, right? Oh, it's 56. That's I did it wrong. Dang, we just missed it. So then plus 8 again equals 64. No, 56 would fit. Right? Let's keep reading.
Subnet count versus rounded down octet. You're right. Number of subnets equal to 2 borrowed bits. These two things answer different questions. 2 borrowed tells you how many blocks exist. Rounding down tells you which block a particular address is in. Count versus location. The connection is only that both come from the same split, 3 borrowed bits, 8 blocks, each 32 wide, and rounding locates you among those 8. The rounded down value doesn't feed into the count formula at all. 4, 5, 6, the mask value in the interesting octet. It's the sum of the place values of the frozen bits in that octet. Frozen, not free. 3 frozen bits, 128 plus 64 plus 32 equal to 224. And no, it's not the same as the mask, it's 1 octet of it. The full /19 mask is 255.25 4.0, octets fully left of the line, and the interesting octet holds this in-between value. Why it matters? It's the bridge to everything else. The mask value is the only ingredient you need to compute block size. 256 minus 256 minus 256 minus. So the chain is...
Studying for CCNA or already passed?
I'm studying for it right now. So I hate when it freaks out. 256 minus 224 equals 32. That's exactly what I did. And the block size is what lets you locate the network. So I have, so I shouldn't have done this because that's not going to get me there. But 32 times 8. What's 32 times 8? 256. Okay, so I was backwards. I understand it now, or at least I understand it better. So from what I just kind of figured out, and please, for the love of it all, let me know if I'm wrong. We figured out the block size. So we did that by figuring out how many of the borrowed bits we have, which is 3. So we did 2 to the power of 3, which is 8. So we have 8 blocks.
Good luck, man, you got this.
Thanks, man.
I passed in 2025, basically only using Jeremy's IT lab with his flashcards and Packet Tracer labs.
Look, I'm not going to lie. The flashcards are really good, but man, they suck. I hate doing them. All right. 1, 2, 3, 4, 5, 6, 7, 8. So those are our 8 blocks. So those are our 8 host networks. What we do, we can get it 2 different ways. So this is my problem, is that I've been trying to figure this out, and I've actually started using like 2 or 3 different methods. There's one method where you figure out the mask value of the octet, and then you subtract it from the block size, or you subtract it from like the total. So the mask value in the octet is 128 plus 64 plus 2, which is 124. Subtract that to 256, subtract 224, you get 32. So our block size is 32, but the number of blocks that we have is 8. So theoretically, if I did 32 and I just kept adding 32, so that'd be 64, and then add 32 to that again, that would be 96. And then that would be 8, 9, 100, 1, 2, 3, 128. Yes, that is correct. And then 8, carry the 1, that'd be 3, that's 6, 160, and so on and so forth. Although I think I can do this. $192, yes. And this should go all the way up to 256. So the target octet that we're looking for, the target octet, which is this one that we're looking for, is whichever one that this one falls inside of. This one doesn't fall inside of this one. Yes, it does. But if it would have been 97, it would have fell inside of this one. Okay.
Great list. And question 7. Block size. Its whole job is exactly what you guessed in question 8. Yes, you use it to find the network address, round the target octet down to a multiple of it. That's why you need it. But it is not the number of addresses in the subnet, except in the special case where the line lands in the 4th octet. Block size counts steps in one octet, and each step drags all the octets to its right along with it. Here, one step in the second octet, equal to 256 times 250.
So I could have divided, after I figure out the block size, I should be able to divide that by 256 and get 32. 256 divided by 8. So what I really need to do is find the block size, divide it by 256 to get this. Well, no, that's to get the block size. Okay. So there's two ways to get the block size. I can either take the full mask value of the octet and subtract it by 256, or I can take the total number of blocks and divide it by 256. Both of these is going to get me the block size. Then the target octet is determined based off of the amount, because the amount of subnets that we have. Okay, no. This is... Fuck, dude, I'm so close. This block size is the number of addresses that is inside each block. This tells us how many blocks there are. This just tells us how many addresses there are. It doesn't tell me how many usable addresses there are. Just tells me that there are addresses. And then what I have to do is figure out which one that this one falls into. So that means that 57 falls in the 32 targeted octet. So, okay. I think I understand it. Example. 192.168.5.56/27. I can get the block size. Yeah, I can get the block size two different ways. One, I figure out the mask value of the interesting octet, and then subtract it to from 256. 256. 2. This makes more sense to me. I gotta put parentheses. I know that's really stupid, but I gotta do it. Hold on. Thank you. 2. I figure out the block size by using 2 to the power of none of borrowed bits. Yes. 2 to the power of borrowed bits. And then dividing that number by 256. Because 2 to the power of borrowed bits. Because 2 to the power of borrowed bits is the number of subnets that... That's what's wrong with my signal. Buddy, I think one of my ports just died on my Switch. That's why my signal's been so like crappy lately, is because I've been running on Wi-Fi instead of a hard connection. That's crazy. Okay, anyway, that completely broke my train of thought. Let's get back to this now that I've fixed everything. Okay, because 2 to the power of the borrowed bits is the number of subnets that I have. And the number of subnets that I have divided by 256 is the number of addresses in each subnet. Addresses in each subnet. So, for our example, the first 3 bits in the interesting octet are the borrowed. What are you doing? What are you doing, cat? What are you doing? Okay. Are the borrowed bits. 128, 64, 32. So that means it is 2 to the power of 3 equals 8. So there are 8 blocks. I then divide. Have I been misspelling divide? What? I then divide 256. Where's my divide button? Divided by 8, which then equals 32. Therefore, there are 32 addresses in each subnet. Whoa. Okay. Addresses in each subnet. Only 30 of them are usable. Okay. So, to find out which subnet grouping that our example lives in, we just need to figure out which grouping it falls. Our groupings are, I don't want to say groupings. Our subnets are 0.32, 0.64, 0.96, 0.128, 0.160, 0.192, etc. No, I don't want to say etc. Just finish it out. 192 plus 32, 224. 224, and then after that should be 0.255. Please, for the love of God, be it. It's 256. 256. In the subnet that our interested octet falls into, '57. Falls into is 0.32. So the network address for our example is 192.168.5.32 slash no slash yes slash 27. Question: does this mean that if I were to look at the lowest bit in the borrowed octet, that it would tell me the block size? So in our example, the 3 bits that were borrowed were 128, 64, and 32. Does that mean that 32 is the block size? Because it is the lowest in the borrowed set. All right. Oh, I think I understand it. This is gonna confirm my understanding, or it's gonna tell me that I'm wrong, and then I'll probably cry. Oh, baby, that's what I want to see. Yes, exactly.
Yes, exactly. And you've just rediscovered the rule from your very first message. Go to the last bit of the frozen network bits. That is the block size. Now you can see why it works. The lowest borrowed bit is always equal to 256 minus the sum of the bits above it.
Oh my God, that makes sense. So you don't need to subtract anything. You just need to know what the lowest bit is.
Minus the sum of the bits above it. 109.
Hold on. What are you doing?
92 and 256 minus 192, add the 32, and 256 minus 224 equal
I
to
hate when it freaks out. It can't read numbers very well. Okay. The lowest borrowed bit is always equal to 256 minus the sum of the bits above it. Okay, that makes total sense. So 128 plus 64 equals 92, and 256 minus 192 equals 64. Add the 32. 128 plus 64 plus 32 equals 124, and then 156 minus 254 equals 32. Okay, that makes sense. The subtract method and the lowest bit method are the same fact viewed from two different sides. Excellent. The lowest frozen bit is the fastest shortcut of all. So I just have to figure out what the lowest bit is, and that tells us what our block size is. Okay, and that's what we need to figure out what our network is. Here is let's see here. Will it do it?
Here's the intuition for why it must be true. The network portion is a counter that's only allowed to use the frozen bits. If your frozen bits are 128, 64, and 32, then the smallest possible step the counter can take, flipping just the lowest bit, is 32. So consecutive networks are forced to be exactly 32 apart. The spacing between networks is the smallest increment of the network counter, which is the place value of its lowest bit.
The smallest spacing between networks is the spacing between the networks is the smallest increments of the network counter, which is why when it's /24 it's 128. No, sorry, when it's /25 it's 128. Yes. Okay, don't confuse yourself. Your worked example is right. 75 falls in between 32 and 64 network. Network is 192.168.532, but two fixes in your subnet list. You wrote 32, 64, 96, 128, which drops the first block, okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, when in reality it should have been 0.32, okay, which drops the first block and invites an impossible one. The list starts with 0. You said it yourself 2 messages ago because we count 0. Okay. Yeah, this doesn't exist. The octet maxes at 256. Or 255. The last block starts at 224. Yes. Okay. And runs through 255. Yes. Which one is one quick test, the shortcut. What's the block size from reading the lowest frozen bit? What's the network? So 29. So 8, 16, 24, 25, 26, 27, 28, 29. It would be 8. Right? 24, 25, 26, 27, 28, 29. So the line would be right here. Isn't the block size 8? And then if it's 8, hold on. The block size is 8. And then that means 8 divided by 256 So that means that there's one, two, three, four, five. Hold on. What's 5 to the power of... No. 2 to the power of 5, which is 32. Damn, I just confused the shit out of myself. $32 is 8. So the block size is 8. So that means the blocks, according to this, the block size is 8. And there is how many networks that are in here? 2 to the power of 5. There's 32 networks. Each network is going to have 8 in it. So 8 well, then let's divide 8 by 40. No, sorry, let's divide 40 by 8. My bad. I always say that backwards. So it's going to be the 5th one. So 5 times 8 is 40. Whoa. And wouldn't the network be $29? 8 it so 2 to the power of 5. 5 being the number of borrowed bits. 5 being the number of borrowed bits. Equals... Crap, what was it? 32? 2 to the power of 5. Yeah, 32. Equals 30. Dang it, dude. I hate that you have to hit it 3 times. Equals 32. Equals the number of subnets. Did we divide, right? $256 divided by 32 should equal 8. 256 divide by 32. Yeah. Divide equals 8, meaning that 8 addresses are in each subnet. Point 0, point 8, point 16, point 24, point 32 point 40. So what do you got for me? Both right. You walked straight through the twist without flinching. So let's make sure you noticed it. 40 itself is itself a multiple of 8. It rounded down to itself. The address and the network address are the same thing of the numbers, which is a sneaky sequence. Can't be assigned to a host. That address is a network identifier for the block. For the full chain looks like this: network point 40, first host 41, last host 46, broadcast 47, next subnet is 48, only 6 usable hosts. Yes, all of this makes sense. Your reasoning chain was clean too. Okay, so that means that I need to fix my worksheet. I need to fix my worksheet to make it match this. So if we go back to this, we went down this really long rabbit hole, but I really think it was 100% worth it, because we are now able to do this, or at least I'm able to do this. The block size is 32. We have 8 subnets that are here, which means we just have to figure out what this is. So 56 would fall in here. So the network is 32. If it was 97, it would have fallen in 96. Okay, and I only used 97. Like, I pulled that out of my ass. Like, that was literally nothing. I just pulled a number out. Okay, let's see if we're correct. We should be correct.
Now the last octet is 00100000. Change that back to dotted decimal, and you get 192.168.5.32. So that's the answer. The host, 192.168.5.57/27, belongs to the subnet 192.168.5.32/27. Let's do one more for practice. What subnet does host 192.168.20?
Okay. Let's do this. So, go here. Let's reset the pin. All right, we should be good. We're cooking with gas now. So we have 192.168.
Please tell me English.
Please, I will. Give me 1 second. I'll walk you through this, okay? 168, 29, 219, 29. Okay, so our CIDR is 129. That 129, it tells us the amount of bits that are being taken up. So all 8 of these, so that's 16. This is 24, 25, 26, 27, 28, 29. So that means that our division is right there. Now, our lowest block right here that we see, that is our block size. Okay. Now I'm going to walk you through how we do that. Okay. What we do is we take 2 to the power of 1, 2, 3, 4, 5 to the power of borrowed blocks. This equals 32. Now, to get our block size, there's 2 ways to do it. We figure out what the mask is, put it here, and then subtract it. Or we take this and we divide it. So 32 divided by 256. Okay, should equal 8. So 256 divided by, not 8. Yes, equals 8. So that's our block size. So what does this mean? This means right here this is the number of subnets that we have. So I'm not going to draw 32 of them. 1, 2, 3, 4, 5, 6, etc. all the way to 32. Inside of each of these 32 subnets, there are 8 addresses, which only 6 are usable because 1 is the broadcast and 1 is the actual network itself. So what we just have to do is go up by multiples of 8, okay? So we start with 0, then we go up to 8, then we go up to 16, 24, 32, and then 40. Now, we have to keep going until we hit 219. Or we can divide the block size, because that's the number of addresses that are possible, by 219. So here we go. 219 divided by 8. Now, the answer is 27.3 yada yada. We don't care about that. We don't care about the point. We're going to drop the remainder. So 27. That means that if we multiply 27 and 8, that gets us 216. Now, the reason we multiplied it, well, let me back up. The reason we divided it is that we have to figure out where this is. So if we were to keep going all the way, we would eventually hit 216. Okay? 216 is a multiple of 8. It's the 27th subnet of this 32 that's right here. Okay? So what that means is that this IP address, 219, is inside of this network. So our network is 216. Of course, it would be 192, 168, 29, 216. Let's see if we're right.
29.219/29 belong to. Pause the video now and try to figure out the answer for yourself. Okay, let's check. Write out the address in binary first. Identify where the network part ends.
Okay, that's what we did right there.
In this case, 5 bits are borrowed from the host portion and added to the network portion. Set all of the host bits to 0, and then convert back to dotted decimal.
Now, what he did was also really interesting. And it's another little shortcut. And I actually understand it now. Because and let me test it real quick to make sure that I'm correct. 128 plus 64 plus 32 plus 16 plus 8. No. Okay. Now I understand it now. Okay. So what he did is he took a shortcut by taking the frozen bits, or the bits that were free, and he zeroed them out. And when he zeroed them out, he was only left with the subnet that is being currently used, which is actually really smart. That's really good. So we were correct. 216.
There's our answer. So, host 192.168.29.219/29 belongs to the subnet 192.168.29.216/29. Okay, let's review some numbers. This is a table of the different subnet sizes.
I don't care about this.
Okay, before moving on to the quiz, let's do one more identify the subnet problem. This.
Okay, so yeah, we're going to do one more. And we're going to do it his faster way. Okay? Or Or maybe we won't. I don't know. We'll see how it goes. 172, 25, 217, 192 / 21. So here's 8, 16, 17, 18, 19, 20, 21. So it's going to be a little bit bigger. So theoretically, we should be able to do this. 128 plus 64 is 192. We're converting this into binary. Plus 30. No, not plus 32. Son of a bitch. 128 plus 64 is 192. Okay, then plus 32, which is 224. So we can't do that one. Okay. So then now let's add 128 plus 64 plus 16. Ugh, I hate my life. I hit subtract instead. 64. I guess we could do this. Plus 64. Plus, no, we can't do 32. Plus 16. 208. So that means 16's in there. Okay, now we're going to plus 8. So let's go here. We know it's 8. Can't be 4. Can't be this. That equals 217. What we do is zero this out. So our host is 216.
This time with a Class B network. What subnet does host 172.25.217.192/21 belong to? The process is exactly the same as with a Class C network. Write out the address of binary.
I did it wrong. Hold on. I put it in the wrong spot. 216.0.
Change all of the host bits to 0, and then change it back to dotted decimal. Pause the video if you want to try it on your own. Okay, let's check the answer. Here's the address written in binary. As usual, the red bits are the host bits, and the purple bits are the borrowed bits, which are now part of the network portion.
Look, we did it right.
Change the host bits all to 0, convert it back to dotted decimal, and you get 172.25.216.0.
Yep.
So, there's the answer to the question. 172.25.217.192/21 belongs to the 172.25.216.0/21 subnet. The process was exactly the same as for a Class C network. There are just more host bits. Here's a chart like the one I showed you for Class C addresses, showing the number of available subnets and the number of available host addresses for each prefix length when subnetting a Class B network.
Okay. Okay, we're gonna call it there. We're gonna call it done. I feel really good about this. Okay. Now, I'm gonna try to change my worksheet here so that way it makes a lot more sense and it's a little bit more user friendly. I've some pretty good ideas of what I'm gonna do in order to make it better. But I legitimately feel like I kind of understand what's going on now. I hope that you do too. I know that this was a long, like me just typing things out and like watching me figure things out, but I hope that it helped in some degree. Anyway, that's it for the stream. We will be learning new things moving on to the next video on Monday, tomorrow morning at 8 p.m. or 8 a.m. I will catch you guys there. And please, if you have not already, subscribe to Jeremy's IT Lab. And if you haven't already, subscribe to my channel as well. Okay, I'm really gaining a lot of subscribers. It's very cool. Thank you so much. Appreciate all the love and the support, and I hope that I'm helping you guys as I try to figure this stuff out on my own. Okay, I will catch you guys tomorrow morning at 8 a.m.